there, let's meet again. My name is Edgar Dexas Nyamoyo. My email is dexasedgar@gmail.com. This is the courtesy of Eagle Girls, and just a continuation of our physics class, that is uniform circular motion. We've looked at the definitions and different definitions, and we just derived some formulae. We arrived at this point where we were looking at the omega velocity, and at the omega velocity we realized that we relate from the linear velocity, and we realized that the linear velocity is the change in displacement you divide by the change in time. That's what we learned in Form 3, that is under linear motion. That is the first topic in Form 3. Then again we were deriving something here, and we wanted to see the relationship between theta, s, and r, where s, remember, is the arc length, the length of a point here. It is from s, that is from A to B, and the radius is just the distance from the center to the circumference. And we realize that the arc length, if we divide it by the radius, we get theta. But we just talked through, we did not show it, and here it is for those who do not follow. We realize that C is the circumference, which is equals to 2 pi r, and if you want to get the length from A to B, that is L, we'll take it to the theta over 360 multiplied by 2 pi r. Theta, we want to make theta the subject of the formula, where L, if we cross multiply all through by 360, you realize that theta will be L multiplied by 360 over 2 pi r. And in our previous class we agreed that L is S, where S is the distance between A and B. So if we replace L with S, theta will change to be S multiplied by 360 over 2 pi r. Although I've started with r 2 pi, there's a reason, because I want to eliminate 360 over 2 pi, because we agreed in the previous class that 360 over 2 pi is just 1 radian. The 1 radian, if you can remember from the previous class, is just 1 radian is equals to 57.29329 degrees. So 360 over 2 pi, if you have a calculator there, you can use it and you can get 360 over 2 pi, you'll get 57.29. So that if I can eliminate 360 over 2 pi, I'll get theta is equals to S over R radian. So our angle, it will be specifically 360 over 2 pi, which is our angle theta. It will be specifically in radians. So don't give angles in degrees or in other unit. We will be giving it in radians, because the SI unit of radian is the SI unit of angular displacement is radian. Rather, sorry for that. Now we can look at an example here, and the example is find the angular velocity of a body moving along a curve AB 6 centimeter and radius 3 centimeter. From the center, if it takes 2 seconds to move from a point A to B. So in this question, I think we are given now let's start solution. In this question we are given 1, A to B, that is I think a curve which is 6 centimeters, and then we have the radius, that is R, 3 centimeters, and we are given the time, which is T is equals to 2 seconds. So our problem is made simple if we can know what we are looking for. Now the first thing we are supposed to know is the formula of angular velocity, which is omega equals to theta over t. T is just change in time, and in our case we are not given theta, we are only given t, which is 2 seconds. Now from our previous class, we remember that theta, that is angular displacement, is just S over R, where S is the arc length, and in our case our arc length is given as AB. So along a curve AB 6 centimeters. So in other words, we are given our curve S, that is the distance S to be 6 centimeters. Now if we have S, we have R is 3 centimeters, then we can find theta as theta is equals to S over R. S is 6 centimeters and our R is 3 centimeters. So since they are both in centimeters, no need to change S and R or R to SI unit. Somebody may say, why don't we change to meters? So no need, because if you realize that centimeter and centimeter are going to cancel, so you'll get 6 over 3, which is actually 2 radians. Remember, the SI unit of angular displacement is radians. That's what I'm stressing in. So if we come back to our omega, omega is our angular velocity. It's equals to theta. Theta, we've gotten it to be 2 radians. You'd find by 2 seconds is the time given. So you realize that it will be 1 radian per second, and that is the angular velocity according to according to question given. Thanks for watching. If question, you can wire it to me and I will be there to answer you. Thank you very much and be pleasant.